All you math fans out there. So today for Math 370, we're going to do section 12.3. It's a different type of sequence, the geometric sequence. And this one I like a lot. This one's kind of fun. I like it a lot better than the arithmetic one. To me, it's more interesting, which, math teacher said it's more interesting. It means it's got to be more difficult. No, not necessarily. So let's just see what it is, and I'll let you decide for yourself. So a geometric sequence, all terms increase or decrease by a common multiple or ratio. The arithmetic sequence, you added or subtracted the same number every time. The geometric sequence, you're multiplying or dividing by the same number every time. So there's a common ratio, which is r, just make sure it's not 0. And then the nth term is given by a, or your first term, times r to the n minus 1. So for example 1, find the nth term. We've kind of done this a little bit before, or we've seen this one before. It was like you're multiplying everything by 2. So let's just identify what the a is and the r. So the a is always the first term, so the a is 2. And the r, it's like, okay, well, what are you multiplying every time to give you the next term? Well, the r would also have to be 2. So you end up with 2 times 2 to the n minus 1. Well, this is one that you can actually simplify because the bases are the same. So it's really just 2 to the n, because you can add up the exponents and the ones cancel. That doesn't happen all the time. Every once in a while it does, so just kind of be aware of that. So like on B, your a is 7, and the ratio in this case is still 2. So your nth term would be 7 times 2 to the n minus 1. And you can't combine those because the bases are different, so just leave it alone. And then for C, your a is 6. Your ratio is 1/3. So then your nth term would be 6 times 1/3 to the n minus 1. Okay, so I'll let you, or well, actually, let's do part D. Actually, maybe even part E, because that one's kind of interesting too. So part D, now it's kind of alternating in sign a little bit. Actually, not a little bit, a lot. So just follow the same patterns that we did before. So your first term is 4, so that's the a. And what are you multiplying every time in there? Well, 4 times what is negative 20? Well, that'd be negative 5. So negative 5 to the n minus 1. And you can leave it like this. You don't have to pull the negative off. You can't combine the bases, so that one's done. So on E, your first term is 6. And then what are you multiplying to 6 to make it 0.6? Well, you guessed it, 1/10. Okay. All right. Example 2, find r in the missing terms, and we're assuming that this is a geometric sequence. So I'm starting with 5 times the cube root of 6, and then I moved on and got 5 times the cube root of 36. So what did I multiply to this to give me the second term? Well, it's going to have to be the cube root of something. Well, something times 6 is 36. So, 6. So that's your r. So to give you the next few terms, just keep multiplying this like all the way down, but sometimes you're going to have to simplify it. So the cube root of 6 times 5 times the cube root of 36 is 5 times the cube root. Now look what you're multiplying together. You have 6 times 36, or 6 times 6 times 6, which is 6 to the third. Well, what happens with a cube root and a third power? They cancel. So your next term is 30. Okay, so the next few should be kind of easy. 30 times the cube root of 6. Multiply the r in there again, so 30 times the cube root, 36. And uh-oh, you're gonna have the same thing happen again. So it's really 30 times 6, which is 180. All right, I'll stop the video there, and then we'll continue on in video number 2.